Hi, everyone. I'm Adib Nasli, co-founder and CEO at Zendi. I want to welcome you all to Zendi University this week. We have a lot of great panels scheduled throughout the week, and we look forward to engaging with you on these. Before we get into a training session that we have scheduled at 10:30, we thought it would be great to just give you an overview of the platform, what we're doing, why we're doing it, and how we are helping and arming folks such as yourself in really taking as much advantage as possible to deliver as much capability as possible into this microgrid market. And with that, I promise not to kill you with slides, but I just want to set the groundwork as to what are some of the challenges that we're addressing, how we're addressing it, so that you have that framework as you go into the training session if you've registered for it. I know we have multiple ones, so it might not be today that you registered. It might be later on in the week. But hopefully this sets the foundation for you to be able to really get as much out from these sessions as possible. And earlier in the session that we just ended, there was a lot of talk about the need for careful planning. But really, when it comes to these microgrids, there are three key pieces that we felt were important to tackle and to arm you with to be able to really leverage and close as many deals as possible, deliver as much value as possible, and be able to do it at scale. So there are three components. One is really turning a microgrid design into a repeatable process. This is really a key piece, not only of being able to de-risk a project, but also to be able to put in place the workflows that provide the acceleration with the sophistication that you need to address these opportunities as they come your way. Next is how to really make these designs bankable. There's the financiers, the utilities, the regulators, they all need credible numbers. And how do you really go about bringing that data to really not only bring confidence, but also get over some of the fear points that some folks may have as systems become more complex. And as we've been hearing all throughout the year, the energy mix in the United States and throughout the world is becoming more complex. The use cases are becoming more sophisticated, and the need to get power into a single geographic location, whether it's a campus or whether it's a facility, is paramount. Some even discuss it from a national security perspective. But when we look into really designing complex systems, whether they're microgrids or any sort of an energy system, there are certain key steps that need to occur. So from conceptual design, through a detailed design, through actually making sure that whatever the plan is survives engineering. So the cabling, the transformers, the ability to make sure that power is going to get from where it's being generated to where it's being consumed in a safe and reliable manner, and being able to hand off to the engineering teams that are going to do the power system studies, whether it's fault studies or time series quasi-static power flows or protection coordination. How do you go about really creating a unified approach to accelerate, keep the sophistication, and not have these disconnects potentially that can drive not only inefficiency, but really put a project's outcomes at risk? And then finally, how do you make sure that that design intent and the operational strategies that were thought through during the planning process, during that detailed design process, actually get implemented? So the first is really looking at what some of the past approaches have been. And when we've looked at them, when we've done surveys within the industry, sometimes we've seen more often than not a very stitched together approach where every step of a process requires another set of software or tools. So a lot of stitching together that creates a lot of handoff risk, lost opportunities because what the customer's intent was, what the initial feasibility said, and then wanting to go into detailed design, all of a sudden the numbers just don't work because completely different math is being used sometimes in each one of these steps. And then you have outcomes that just don't match with what the customer bought. So when it comes to the value streams that they were promised that the system would take advantage of and leverage, we're also seeing inefficiencies there. And all of this at the end of the day means the business case becomes extremely weak or actually negative sometimes. The resilience is not as, I would say, strong as it can be. And the sustainability and emission reduction needs of the project also are typically suboptimal. So how do we solve this? How do we go about it? Well, that's what Zendi is doing. And we address that from multiple angles. And you're going to be seeing some of these today. So we have from being able to look at a portfolio of opportunities. So let's say you have 100 or 1,000 sites that you want to consider. Where do you start? And do you model them individually, one by one by one? It can take forever. So we have our Discover API that under tariff can show you what the system's opportunities are for the technologies you're looking for across a geographic space, whether it's a city, a state, or a nation. But you can really automate that initial pre-feasibility screen to maybe go from those 1,000 sites to the top 100. We have a proposal solution that provides business developers and the frontline sales folks with the tools that they need to give a sophisticated, fast proposal to customers with tariff and constraints, with the capacity sizing of the assets, and then the design platform, which is what the training at 1030 is. And this is where you can get in from very early stage designs to an interconnection-grade design. And what do we mean by interconnection-grade design? We mean not only sophisticated techno-economics, where you get the capacities, the locational value of the assets, so even where you should install them, but also how they should be operated. And then really doing various scenario sensitivities to look at the trade-offs between CapEx and OpEx, but also having a design that will survive engineering, where you can automatically output a single line diagram with a power flow model so that the loading on the cables, the transformers, the losses through that distribution network are all not only being understood by the algorithm, but also being addressed intelligently by the algorithm to help you automate the process, but deliver credible values that the financiers, the utilities, and the regulators are going to want to see, along with the sophistication and speed that you need to put a much stronger business case in front of your customers. And then as that design workflow is automated for you, we then get into that. How do we bring that design intent into operations? There's this gap between planning and then how the system is operated. And how do you prevent that any sort of value leakage that could occur? How do you make these microgrids easier to run? And how do you scale from one site to an entire fleet of sites? And this is where how you operate a system with your certified controls is going to be critical. And there's been a tremendous amount of innovation done by control vendors when it comes to voltage and frequency support, make sure the systems are safe, that they're balanced, or they're operating in a secure way. But then how do you optimize it so that it can actually deliver maximum benefits in a dynamic real-time environment? And you'll get some exposure to that as well. But our entire goal has been to arm you with a consistent science-based platform to deliver value at each of the critical steps within a project. Every one of these steps that I showed in the previous slides, they all use the same underlying algorithm. So the platform, the math is the same. These are just different views into the generative algorithm, depending on the use case, whether it's a lot of automation and speed required for pre-feasibility to scan an entire portfolio, whether it's to deliver proposals with limited information from a customer, and you're not sure you want to make an investment into getting more detailed information to a customer before you understand the strength of a potential business case, to detailed design and operations. It's a single unified algorithm that spans these, but it's being deployed in different use cases. What that means is there is no disconnect through each one of these steps for you, and there's a feedback opportunity from what is being observed in reality into the next plan that you get engaged in. So the designs become more accurate to reality. The Bankability of the projects improves because you now have transparency when it comes to your life cycle costs. You have dispatch-aware economics, not just some static spreadsheet, and you have justification for resilience investments as well. But you need this level of integration in a unified workflow. At least we feel the industry needs it to be able to achieve those outcomes and really address some of the key levers that any sort of a sophisticated energy project is required to deliver on. And then when we look at the stakeholders and what is presented to them, you will see how the reporting, how the interface itself speaks to different stakeholders. We've tried to make the planning process, which the training will cover, a visual language, if I can use that term, where the assets are geospatially, being able to really look at the site and then being able to deliver outcomes that speak to the financial stakeholder, the asset owner, but also the utility and the EPC as well. So very sophisticated, reliable technical package that includes one-line diagrams, power flows, dispatch strategy, how the optimized time series dispatch addresses demand charges, peak shaving, outage ride-throughs. We call it fight-through capability for your system, whether it's hours or weeks, along with those economic outputs that investors and folks that are putting money at risk behind a project require, whether it's the basics such as the IRR on a project, payback and sensitivity analysis, all the way to emission sustainability reports, really addressing all the key metrics from cost minimization, resilience, emission reduction, even redundancy. Do you need N+1, N+2? And this becomes really critical for mission critical facilities where if you're going to be in an islanded mode, you have your asset, but then what's your assets backup plan? And again, the planning tool addresses this in a very sophisticated, but very accessible and easy way. And I hope you enjoy the hands-on experience that you'll have today. And then finally, how do you make sure that the microgrid delivers the modeled value after commissioning? So you have these great plans and you have these great projections, but if a control system is going to come in and follow a completely disconnected set of rules and logic on how the system is going to actually behave in reality, the opportunity to see the benefits is going to be minimized at best. So how do we optimize and make sure that those benefits are actually going to get delivered? And that's where Operate comes in, and you'll get exposure to that too. But it's an innovative new approach that brings in model predictive control capabilities to the certified controls and energy management systems out there. So it takes them from this rules-based architecture, which is very rigid, inflexible, leaves a lot of money on the table, to then being able to deliver an AI-powered predictive control system. The AI is used for forecasting of the load and renewable generation, while the optimizer is optimizing the dispatch continuously. So how do you take that real-time operations into the next level is where Operate comes in, and you'll have some exposure to that as well. But this brings the ability for you to connect the planning with operations on after the commissioning of the system, so that there is no value left on the table, that you're capturing as much benefits as possible within a real-time environment. Sun shines, sun doesn't shine, loads change, real-time pricing might change, demand response signals are going to come in, lots of complexity, and we have the brain with our algorithm to really crunch those numbers and deliver really reliable, sophisticated dispatch strategies to all of the modern microgrid controls out there, and energy management systems and SCADA systems as well. And this is just a view into the interface. Again, everything is designed for not only visualization, but decision-making under high-stress conditions, but also a high level of automation where you can just let the system operate and know that it's doing the best that it can to capture as many value streams for you to deliver as much benefits for the system that you have either planned, designed, commissioned, or that you're owning and operating. And these are some of the value streams that we unlock that, again, you have them on the planning side, but now we're making sure that they're captured in a reliable and efficient fashion in the real-time environment. So with that, I'm going to wish you all a great upcoming training session and panels today, tomorrow, and throughout the week. And I look forward to being part of the conversation with you all. Thank you. And we appreciate you being part of this community with us.